All right, so with 8.5, we're going to be adding and subtracting rational functions. So I have included the properties here if this helps you. These are just kind of some notes and examples of what addition looks like and what subtraction looks like. You'll notice that they have to have, or they're combining the denominator. So if we look at number 1, are the denominators the same? Yes. So since the denominators are the same, then I can just combine the numerators. It is subtraction, so what do I need to do with the signs of the second?
Flip them.
I need to flip them, so it's minus w, and then it would be plus 5. So I would flip those signs since it is subtraction. So if I'm combining them, I would have 5w plus 1 minus w plus 5, and all of that over 2w. So then the last steps would be to simplify if possible. So I want you to leave it in factored form, but if there are no factors, then you would simplify if possible. So I'm going to simplify this. That means I can combine the 5w and the minus w to be 4w. And then the plus 1 plus 5 to be plus 6 over 2w. Can I do anything after that? No. The w's cannot cancel because they are terms, not factors. So remember that from the last class. Like the 4w and the 2w cannot cancel because I have this plus sign in between. So since they're not factors and they're just terms, they don't cancel. So that would be my final answer. For number 2, I'm going to do the same thing. So I'm just going to combine the numerators because my denominators are the same. So I would have 3a and 5a. That would combine to be 8a. And 10b minus 2b would be plus 8b over 4. Okay, then last step is I want to simplify. So is there anything that I can do the numerator to simplify that? Is there a greatest common factor that I could pull out? An 8. So if I take an 8 out of the top, I am left with a plus b over 4. Now is there anything that I can cancel? The 8 and the 4. So I can cancel those, and what would be left? 2a plus b. And I'll just leave it in parentheses. I don't need to FOIL it back out or multiply it back out. I would just leave that as my final answer. All right, so let's look at number 3. They have different denominators. So I have an a and I have a b. So if I have different denominators, how could they become the same denominator? Finding a common denominator or least common multiple. And so if I wanted to combine them to be the same fraction, what would my denominator need to be? AB, perfect. So my denominator would need to be A times B. And so if you think about the first fraction that I have, if I'm getting my denominator to become AB, what do I need to multiply the whole thing by? B. So then this would become B over AB minus, and then the second fraction, I'm needing that to multiply by what to make my denominator AB? A. So A over AB. So then my final answer, if I were combining, since now they have the same denominator, it would just become B minus A over AB. I can't do anything further. I can't pull anything out. So for number 4, the common denominator would be 5w. So for my first term, I'm going to have to multiply that by w to make my denominator 5w. So I would have w squared plus, I have to multiply the second term by 5, so plus 25. That cannot factor because it's plus 25, so I can just leave it like this. There's nothing else that I can simplify. All right, so we have decided that the least common multiple between these two, if I were to create a common denominator between 5 and 6, that would have to be 30. And then c and d squared, I would just have to put both of those on the denominator. So I am creating my denominator to be 30c d squared. Then I have to look at each fraction and think, what do I multiply this first fraction by to make my, so what do I multiply the 5c by to get 30c d squared? 6 and then d squared. So I'm multiplying this 2 by 6d squared. And so that becomes, if I do 2 times 6d squared, that would be 12d squared. And then my second fraction, what am I multiplying that by? The 6d squared to get 30cd squared. 5c. So this would be, so this times 5c would get me 5c squared. And so then I'm just going to simplify this one more time to be 12d squared plus 5c squared over 30cd squared. Now, nothing will be able to cancel because they don't have, like, neither of these two terms at the top have anything in common. So since they have nothing in common, I cannot cancel them. All right, so what is the common denominator between 7a and 3a? 21a. 21a. Because I just need to find the least common multiple between 7 and 3. They both have an a in common. So if I make my denominator 21a, if you made it 21a squared, that's okay because the a's will end up canceling in the end, like if you re-simplified it. And so in order to look at this first fraction, to get my denominator to be 21a, I need to multiply the whole thing by 3. So when I multiply the bottom by 3, I get 21a. When I multiply the top by 3, I get 6a minus 15b. Then if I look at the second fraction, remember you have to distribute the negatives. So minus a and plus 4b. In order to make the denominator 21a, that means I need to multiply it by 7. So I would multiply the whole thing by 7. So minus 7a, and then 7 times 4 is 28, so minus 28b. Then I'm going to combine my like terms. So 6a minus 7a, I'm going to come up here and finish it out. 6a minus 7a is negative a. And negative 15, negative 28 is minus 43b over 21a. Okay, so when we have unlike denominators, which we kind of have already seen, you can always find a common denominator by two rational expressions by multiplying their denominators. So the cross-multiplying thing that we talked about earlier, that would work for anything. But it's not always necessarily multiplying the two denominators together. Sometimes there's an even easier, more simple way to do that. So on the last example on number 6, we could have used 21a squared, and that would have been by multiplying their denominators. However, if you use the least common denominator, which is the least common multiple, you may have less simplifying to do. So that's why we used 21a. So what this is saying is that you can use either one. You can multiply their denominators and that'll work every single time. But if you think about what's the least common multiple, that may be a little bit easier and you won't have as much simplifying to do in the end. So if we look at number 7 through 12, we're going to determine what their least common multiple is. What would the common denominator be if they were both on the denominator? So if we look at number 7, we have 24 and we have 16. So what would their least common multiple be? If I could make them the same number, what would that be? And you can use your calculator too to try and figure that out. So between 24 and 16, they would both be 48 because I could take 24 times 2 and 16 times 3. And that's my least common multiple. So you're just trying to figure out what the common denominator would be. Okay, what about number 8? What would 15 and 8 both have in common? Like if I were to make them a common Yes, it is 120, so you may have to use your calculator for these. Okay, number 9, now we're going to have some x's in it. So number 9, if you're trying to picture like what the least common multiple would be, imagine having 1 over x plus 1 over x minus 1. How could I combine those? X squared minus x, or I'm going to leave it as x times x minus 1. I'm going to leave it in factored form because whenever we start factoring things, it's going to be a lot easier to cancel. So leave in factored form. So for this one, these both have 3 and x and squared in common, but this minus 3 is kind of by itself. And so I could write this as, like if I were to take a 3x squared out of 12x squared, I would be left with 4, right? And so 12x squared minus 3x squared. If I were, here, let me do it this way. If I were to take a 3 out of this right here, I would be left with 4x squared minus 1. And then I could factor that to be 3, 2x plus 1, 2x minus 1. So this right here would be my least common multiple because 3x squared goes into 12x squared minus 3. Like they both have a 3x squared in common. I just factored this out a little bit further. So the stuff that I have boxed in orange right here, that is my least common multiple. I just simplified it. Because the 3x squared goes into 12x squared. So since it goes into it, it would work. It would be like having 12 and 24. The 12 goes into 24, so my least common multiple is 24. Does that kind of make sense? Like since the left side goes into the right side, it's contained in it, so then therefore the 24 is my least common multiple. All right, look at number 11. What can I do with this x squared minus 16? As a difference is squares, so it becomes x plus 4 and x minus 4. And then on the right I have x plus 4. So since that x plus 4 is contained on the left, then this becomes my least common multiple. So since like one is contained in the other, x plus 4, x minus 4 is my least common multiple.
Would it not be x squared minus 4?
I would want to go ahead and factor it so that you can cancel.
Like number 10, would you not do anything with the 3x squared after you get 3, 2x plus 1?
No, because 3x squared is contained in 12x squared. Okay. Since it's contained in it, you just choose the bigger one. Okay? So let's look at number 12. I can factor both of these. So how do I factor the left side? X minus 4 and x plus 3. And then how do I factor the right side? X plus 3 and x minus 3. And so I'm going to, for my least common multiple, it's going to be all of the parentheses that are different. There's one that I have in common, and I only have to write that once. So which one is repeated in both of them? X plus 3 and the x plus 3. I only need to write that one time whenever I'm doing least common multiple. So my least common multiple would be x minus 4, x plus 3, x minus 3. So I only need to write the x plus 3 one time since it's contained in both parts, like in both the left and the right. So if I look at number 13, I have, if I wanted to combine those, what would my least common multiple be? If I put these in parentheses, that might help. Is there anything that they have in common, or would I just need to multiply the denominators? I would just want to multiply the denominators because I can't factor anything. There's nothing I can do with it. So my least common multiple, or what my denominator will be x plus 2, x plus 5. And this is where the cross multiplying thing comes in. So on the left side, since I have the 5 over x plus 2, I need to multiply the numerator by x plus 5. So on the top, I'm left with 5x plus 5 minus 8x plus 2. Yeah, so minus 8 right here. Then the minus will...
But why would you put the x plus 2 and x plus 5?
For what part? Oh, this is the denominator right here.
We're not supposed to distribute.
All right, so then I'm going to simplify this by multiplying it out. And I'm going to come up here because I kind of ran out of room. So if I distribute the top, I'm left with 5x plus 25 minus 8x minus 16. And I got the minus 16 by, I FOILed out the negative 8. All over x plus 2, x plus 5. Then I combine my like terms, so I have 5x minus 8x, which becomes negative 3x, positive 25, negative 16, so that becomes minus 9, or plus 9, sorry, all over x plus 2, x plus 5. And then, is there one more thing I can do to simplify? Negative 3. So I can take a negative 3 out of the top. So in these kind of questions, you're just constantly looking for how can I make this more simple? How can I simplify this even more? So the things you're doing, you're trying to factor, you're trying to pull out a greatest common factor. So on the top, I can take out either a negative 3 or a positive 3, either one. If I take out a negative 3, I'm left with x minus 3, x plus 2, x plus 5. So that would be my final answer. So if you try number 14, I'm going to put the answer on the board. 5x minus 6 over 2x minus 1. All right, let's look at number 15. Number 15. So I have these denominators. One is k plus 2, one is k plus 2 squared. So what would my least common multiple be, or what would the denominator need to be to make them the same? K plus 2 squared. So this is already k plus 2 squared. I don't need to do anything with the minus 1 on the end, like on the right. But with the stuff on the left, in order to make this k plus 2 squared on the bottom, I need to multiply the whole thing by what?
K plus 2.
K plus 2. Because when I multiply the denominator by k plus 2, that gets me k plus 2 squared. So then on the top, it is k times k plus 2 minus 1. And so then, if I were to simplify this, I'm going to come up here, k squared plus 2k minus 1 over k plus 2 squared. So since I can't factor this, if you could factor this, you'd take it a step further, but since you cannot factor it, you just leave it as is. We're not going to do any quadratic formula, anything like that for this chapter. Okay, for number 16, the common denominator out of these two is what? 6r minus 24. So for the first fraction, what do I need to multiply this by to make my denominator 6r minus 24? 6. And so I multiply that to the top. That becomes 6r minus, I don't need to do anything to this second fraction, so minus 5r. Then I combine the top. 6r minus 5r is just r over 6r minus 24. You could leave it like that. You would be fine. But I'm always looking for greatest common factors. So both of these have a 6 in common. So I could take an r, or a 6 out of the bottom to be r minus 4. Like that. I would accept either answer. This one is the most correct because you're taking out the greatest common factor. Okay, complex fractions are like when you have a fraction divided by a fraction. It contains a fraction in its numerator and the denominator. So it can be simplified in two ways. One way is easier than the other. Method 1, if necessary, simplify the numerator and denominator by writing each as a single fraction and then divide. Method 2, multiply the numerator by the denominator by the least common denominator of every fraction and then simplify. So the way to explain that in words without having to write out the definition is basically we're going to get rid of the fractions on the top and the bottom by multiplying by the least common denominator. So if I look at the example, my two denominators are x plus 4 and this x plus 4 plus x. So out of all three of those different denominators, what would the least common multiple be? Like if I were to create one big denominator, x plus 4 and x. So x plus 4 times x.
Why would you keep the times x?
Because to combine these two right here, like on the bottom, you would have to do x times x plus 4 because the x doesn't go into the 4, it just goes into the x. Okay, so what I do is I multiply the whole thing by x times x plus 4 over x times x plus 4. So what that is doing, I'm multiplying the top and the bottom by that. What that is doing is it is taking this numerator and applying it to the 5, and it's taking this denominator and applying it to the 1 plus 2 at the top. So let's just take it a fraction at a time. If I look at the top and I multiply 5 over x plus 4 times x over x plus 4, what gets canceled? If I look at the top and the bottom. So if I wrote this out as 5x x plus 4 over x plus 4, what ends up getting canceled?
Wait, you don't want to distribute the 5 to the inside?
No.
Why?
I'm just writing it all as one long fraction. So I'm multiplying the top by x times x plus 4. I'm taking these and I'm applying it to the numerator.
Wait, what happened to the other x?
What other x?
Like, at the bottom?
We haven't done the bottom yet. So I'm just looking at the top right here for now. We're taking it a step at a time. And so then if I do that, what gets canceled? The x plus 4s get canceled. And I'm left with 5x at the top. So that wasn't too hard. Wasn't too bad. Then if I look at the bottom, okay, so now I'm looking at the denominator fraction. If I were to combine these at the bottom and have a common denominator, x times x plus 4, what would I need to multiply this by to get x times x plus 4 as a denominator? X, right? This needs to be x. So I have x, and I'm keeping this as the denominator. So 1x plus, what does this 2 over x need to be multiplied by to get x plus 4? So 2 times x plus 4. Then I want to simplify this a little bit further. So if I were to distribute this 2, I have x plus 2x plus 4. And then I have x over x plus 4. Oh, plus 8, sorry. Plus 8, sorry. And then, let's see. Okay, yeah, let's just not distribute them. So I'm going to go back, sorry. I'm going to do it like we did the top. So if we look at this first fraction, the 1 over x plus 4, the x plus 4's cancel, and I'm just left with, if I have x plus 4 over x plus 4, the x plus 4's will cancel.
What happened to the 2?
Then I'm going to distribute it to the 2 as well. So I have plus 2x, x plus 4 over x, and the x's cancel. Yeah. So then I'm left with 5 over x plus 2x plus 8. And then that is my final answer.
Can't you combine the two x's? So it's 3x plus 8?
Yes. So 5x over 3x plus 8. In number 17, I have 4 different denominators. I have a 6, I have a 3, I have a 5, and I have a 10. So what do they all have in common?
All of them?
Yeah, so 6, 3, 5, and 10. They could all be divisible by what number?
30.
30. So my least common denominator would have to be 30. So I'm going to take the top and the bottom, and I'm going to multiply it by 30 over 30. Okay, so then I'm going to distribute that to the numerators. And so if I look at the top, if I were to take 30x over 6, that reduces to what? 5x. 5x, because 30 over 6 is 5. Plus, then I take the 30 times x over 3. That becomes what? 10x. Then I look at the denominator, same kind of thing. So 30x over 5 is 6x. And then is that a minus? So minus 30 times 7 over 10. That would be
21.
what? 21. And then I'm going to simplify that one more time. And so the 5 and the 10x combine to become 15x over, and then the denominator, can I pull out anything?
A 3.
A 3. 3x minus 7. So then the 15 over 3 would cancel, and it would be 5x over x minus 7. No, then you couldn't take anything else out.
Wouldn't it be 2x? Isn't it 2x?
Yeah, 2. So out of all 3 of these, what do they have in common? X minus 3 x plus 5 over x minus 3 x plus 5. So they have those in common. So I take the top. If I take the top, I multiply it to the top. The x plus 5's cancel, right? And so I'm left with 3x minus 3. I look at the denominator, or the bottom. If I look at this first term, the x minus 3's cancel, and I'm left with 2x plus 5. Then this gets easier. It just takes some practice. And then on this second one, the x plus 5's cancel, and I'm left with plus x minus 3. Does that kind of make sense? Then I'm going to simplify this. So I'm going to leave the top as 3x minus 3 because it's already in factored form. On the denominator, I'm going to distribute the 2. So 2x plus 10 plus x minus 3. And then I combine like terms, so I'm left with 3x minus 3 over 3x. The x minus 3's don't cancel because they're not factors, they're just terms. 3x plus 7 plus 10 minus 3 plus 7.